Good morning to everyone. I am Sandeep from Third EDC, bearing roll number 19BQ180454. And in this session, I would like to discuss about one of the sectional convolution technique, that is the overlap save method. And generally, in practical applications, we come across linear filtering of large input sequences where the length of the input sequence is very large. In such cases, we generally know that the operation is on block of data. Generally on block of data, and the size of that block of data should be very small or limited because the digital process is have limited memory. So in order to process the data, it should be of finite length, right? So in case where the input sequence is of very large length, we have to segregate or section the input sequence into parts, smaller subsets, and we process the input sequence individually. We have to process those subsets individually, and we get the individual responses, and after combining all those individual responses, we get the final output response. So for the same, we have two type of sectional convolution methods. The first one is overlap save method, and the next one is overlap add method. So in this session, I would like to discuss about the overlap save method. So the first step in the overlap save method is we have to determine the length m, where m is the length of the input impulse response data. Impulse response means it is denoted by h of n, and the length is given as m, and we have determined m minus 1. And so in the second step, we have to take the input sequence x of n, and size of the DFT and inverse discrete transform is taken as n, and we take n is equal to 4. And in step 3, we have determined the length of the block L. So as I have said previously, the input sequence is divided into blocks, and the block length is denoted by L, and we can get the value of L. L is equal to n minus m plus 1, where n is equal to 4, and m is the length of the input. Sorry, m is the length of the impulse response, and n is equal to 4. And on substituting this, we get the length of the block. So we have to pad L minus 1 zeros to the h of n. We are given with h of n initially, and we have to pad L minus 1 zeros to the given h of n. So h of n is original h of n plus L minus 1 zeros. This is the third step. And coming to the fourth step, as I have said previously, the input impulse is sectioned into different blocks of size L. So for the in every case, we take L samples of the present block and m minus 1 zeros from the previous m minus 1 samples from the previous block. Since for first block, that is x1 of n, there is no previous block, so we take m minus 1 zeros. And in the following blocks, for example x2 of n, we take the L samples from the present x2 of n, and m minus 1 samples from the previous block, that is x1 of n. Similarly, for x3 of n, we take the L samples from the present x3 of n, and m minus 1 samples from the previous, that means x2 of n, and so on. So in the step 4, we take the circular convolution of the individual blocks with the impulse response. So to get the y1 of n response, we take the circular convolution of x1 of n block and the given input given impulse response h of n. Similarly, to get the y2 of n, we take the circular convolution of x2 of n with the impulse response h of n, and so on. So after getting all the individual responses y1 of n, y2 of n, and so on, we have to arrange them like this in the same way as I have shown here. First of all, we take the m minus 1 zeros, and we take the y1 of n, and m minus 1 samples from the previous response, and y2 of n, m minus 1 samples from the previous response, and y3 of n, and I have to arrange them like this. And on discarding these m minus 1 samples, we get the final output data sequence, that is y1 of n. So let us understand the overlap save method with the help of an example. Let us take h of n is equal to 1, 2, 3. So the impulse response is of length 3. So m is equal to 3, and m minus 1 is equal to 2. And the given input sequence x of n is equal to 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 2, minus 1. And we take n is equal to 4. So as I have said previously, we have to segregate, or we have to section the input sequence into individual blocks of length L. So to get the L value, L is equal to n minus m plus 1. So L is equal to n value is 4, m value is 3 minus 1, we get L is equal to 2. So we have to make the input sequence, you have to divide it into blocks of size L, So make segments of input sequence of length L with adding m-1 samples as I have said previously. So for the first sample x1 of first block x1 of, and there are no previous block, there is no previous block, so we pad m-1 zeros. Here m is equal to 1, so we pad two zeros. It is 3 minus 1, we pad two zeros. And the present x of n, we take the two L samples. That means here L is equal to 2, so we take two samples 1, 2. And for x, similarly for x2 of n, we take the present two samples, L samples on the present input. That means 1, minus 1, 2. And m minus 1 samples on the previous input, from the previous block. So for the x2 of n, the previous block is x1 of n. So we take the two samples from the previous block. Similarly for the x3 of n, x3 of n, we take the two samples from the previous block. That means x2 of n, and two samples from the present input, 3 minus 2. And similarly for x4, x5, and 6, and then x7. And in step 5, we pad L minus 1 zeros to the given impulse response. So given impulse response is 1, 2, and 3. So here in this case, L is equal to 2. So we pad 2 minus 1 zeros. That means 1 0 at the end. So in step 6, we perform a circle convolution to get the individual responses. Y1 of n is equal to x1 of n, circle convolution of h of n, and similarly y2 of n, y3 of n, and so on. So we have all we know how to do perform circle convolution. So first we take the input x1 of n like this 0 0 1 2, and we take the h of n in the matrix form, where the first column is the original h of n 1 2 3 0, and in the next column we this 0 is this 0 will be thrown at the starting, and in the next third column this 3 will be thrown at the starting, and in the fourth column this 2 will be thrown at the starting, and the order follows like this. So on multiplying these two matrices, we get the resultant y1 of n. Similarly for y2 of n, y3 of n, and so on. So on getting all the individual responses y1, y2, y3, and so on y7, we arrange them in the following order, and to get the final response, we discard this m-1 samples. So in this first input response, m-1 sample is 7 and 6, we discard these two, and in second response, we discard 2 and 10, and in the third response we discard 4 minus 6, and so on up to y7 of n, and we take the remaining samples as it is. So on combining all this, we get the final response y of n. So this is how we perform the overlap sieve method. Hope you understand the concept, and thanks for bearing and kindly supporting me. Thank you very much.